Bale, pag nakagawa ka ng Meet link, uh, i-paste mo na lang dito sa income messages or again, dun sa messenger natin. And then, I'll inform you kung kailan tayo lilipat noon. Okay. Let's say 60 minutes naman to. So let us use this time. Okay, so here are the following terminologies of refrigeration engineering or refrigeration system. So, I hope na basahin nyo na to. Um, pero again, di-discuss naman natin yung ibang terms dito as we go on our discussion. Um, pero hindi na natin siya babasahin or di-discuss natin. So, this is more of reading materials again for you. So, if for example, nandito yung term na gusto nyo alamin, then you can read this, this PDF. So we have refrigeration, refrigerant, what refrigerating effect is. We have vapor compression refrigeration cycle. We have absorption refrigeration cycle. So isa-isahin na lang din natin. Nagbasahin in class para mababasa nyo din siya. So gawin na lang natin siyang alphabetical or in alphabetical order. So alam niyo naman siguro yung pagkakasunod-sunod ninyo. Tama ba? Para, alam ko din naman, hindi ito babasahin after ng discussion natin. So, why not? Gamitin natin yung time natin. Siguro, hindi naman siya aabot ng 15 minutes. Hanggang 10 minutes na siguro. So, let us start. Dire-diretso na tayo. Si na lang pala. Sino yung ating dito? Class monitor. Junela. Ayan, ikaw na lang magtawag. Nailisahan ka ba? Hello? Si Junela?
Yes po, ma'am. Good morning po. Ano pong gagawin? Hindi ko po masyado marinig.
Okay. So, bali ito ay ilang bang terms to? Babasahin lang natin in class para at least all of you can also read this. So, kung halimbawa naman hindi naman masyadong mag-gets pa yung mga terms dito. So, at least you are familiar na nandito siya sa terminologies natin para as we go on our discussion, pwede kayong mag-paste dito. Pero,
Ma'am, nadisip po ata kayo.
hello? Ano yun?
Wala po. Akala po namin nadisip lang po kayo.
Okay. So, ayun. Ito ay, yan. Yung ilan na ang nandito. Okay. So, let us start. Basahin lang para at least you have the idea. So again, the refrigeration system or refrigeration engineering is as a course, is a study of different refrigeration processes, its component, controlling system of the processes being done at each section of the refrigeration system. So again, we have here the following useful terminology which we can use in order to study refrigeration system. So let us start. Janela, start tayo. Sino bang una? Ayan, pwede na mag-start. Number 1.
Refrigeration. Refrigeration is a development of a concerned space to have a temperature lower than that which exists in some other adjacent space.
Next.
Refrigerant is the substance used in the refrigeration system. It circulates at different components of refrigeration system, changing the condition as desired by the refrigeration processes.
Okay.
Refrigerating effect is the amount of heat absorbed by circulating refrigerant in the evaporator coil of refrigeration system. By heat balance, this amount of heat is the same as the amount of heat removal from the concerned space or the product to be cooled, considering adiabatic heat transfer with proper insulation of the concerned space.
Okay. So, okay. So, ano ko lang, yung sa pag-gloss parang, ano yun natin na mas maiintindihan yung klase natin. Ano, so, parang, yung makikinig sila. Hindi ko sinabi na hindi nakikinig dun sa una. Para lang sa mga susunod. Okay? So, next.
Vapor compression refrigeration cycle is the widest manufactured type of refrigeration unit applicable to both chilling and freezing process of the product being refrigerated. It consists of four major components such as evaporator, compressor, condenser, and controlling expansion valve.
Absorption refrigeration cycle. Use one or more refrigerant or solution that operates with heat input to the generator of the refrigeration system. A good example are the lithium bromine and the aqua ammonia absorption refrigeration cycle.
Vacuum system refrigeration cycle uses one of the several means of reducing refrigerant pressure to near absolute zero.
Thermoelectric refrigeration process. Use direct current flow through the thermocouples.
Coefficient of performance, the ratio of refrigerating effect to the work of compression.
Next. Next na tayo. Work of compression.
Work of compression. Sige ka muna.
Work of compression is the energy rate to compress the refrigerant vapor allotted to the power input to the compressor.
Overfeed systems are those in which excess liquid is forced, mechanically or by gas pressure, through organized flow evaporators, separated from the vapor, and returned to the evaporators. Some of the terms commonly used with overfeed systems are
Putol pala. Okay. Overfeed system. So, you can read the components na lang for this one. So, we have ano. Okay, so we have evaporator, low pressure receiver, we have condenser, we have high pressure receiver, compressor, and liquid. So that is for over. So now let us move on to the next item.
Low pressure receiver, sometimes referred to as accumulator. This vessel acts as the separator for the mixture of vapor and liquid returning from the evaporators. The pumping unit is located below the low-pressure receiver. A constant refrigerant level is usually maintained by conventional control devices.
Pumping unit consists of one or more mechanical pumps or gas operated liquid circulators arranged to pump the overfeed liquid to the evaporators.
Wet returns. The connections between the evaporator outlet and low pressure receiver through which the mixture of vapor and overfeed liquid is drawn.
Liquid feeds, the connection between the pumping unit outlet and the evaporator inlets.
Flow control regulators are devices used to regulate the overfeed flow into the evaporators. They may be needle-type valves, fixed orifices, calibrated manual operating valves, or automatic valves designed to provide a fixed liquid rate. Advantages of liquid overfeed system. A. High system efficiency and reduce operating expenses. B. The systems have lower energy cost for having fewer operating hours because the evaporator surface is used efficiently through good refrigerant distribution and completely wetted internal tube surfaces. The, the compressors are protected. Liquid slugs resulting from fluctuating load or malfunctioning controls are separated from suction gas in the low pressure receiver. Letter E. Low suction superheats are achieved where the suction lines between the low pressure receiver and the compressor are short. This condition causes a minimum discharge temperature, preventing lubrication breakdown and minimizing condenser fouling. Letter F. With simple controls, evaporators can be hot, gas defrosted with little disturbance to the system. Letter G. Refrigerant feed to the evaporators is unaffected by fluctuating ambient and condensing conditions. The flow control regulators do not need to be adjusted after the initial setting, since the overfeed rates are not generally critical. H. Flash gas, resulting from refrigerant throttling losses, is removed at the low pressure receiver before entering the evaporators. This gas is drawn directly to the compressors and is eliminated as factor in the design of the system low side. It does not contribute to increased pressure drops in the evaporators or overfed lines. I. Refrigerant level controls, level indicators, refrigerant pumps, and oil drains are generally located in the equipment rooms which are under operator surveillance. Letter J. Because of ideal entering suction gas conditions, compressors last longer. This is less maintenance and fewer There is less maintenance and fewer breakdowns. The oil circulation rate to the evaporators is reduced as a result of the low compressor discharge superheat. Letter K. Overfeed system have convenient automatic operation.
Okay, so let us start now from here. Hello. So conjunctively distributed. Hello, or another day. So let us now start our discussion. So isi-share ko tong lecture natin after na-discuss natin lahat. Yeah. Okay. Okay, so I'll also give you 5 minutes and to finish the reading materials for terminologies. Ano, so yung mag-CR ka yung mag-CR muna. Ano, and then we'll continue and start, especially our discussion at exactly, ano ba kung 9. Okay, so patapos na ako ng terminologies, then start tayo. Ano, para dun sa mga mag-CR din.
So again, here is our lecture for Introduction to Refrigeration System. Kindly hands down. Okay. So in this introduction, there is our objective. So we'll be defining refrigeration and also air conditioning in this lecture. So you will have an idea on what air conditioning or how air conditioning works. But it's simple um, definition pa lang naman. Ano, since hindi naman talaga natin totally sasakupin air conditioning. So the next objective is to introduce aspects of various natural refrigeration methods, which includes the use of ice. Ano? So ice transported from colder regions, ice harvested in winter and stored in ice houses. We have ice produced by nocturnal cooling. We have the use of evaporative cooling and then cooling by salt solutions. And then we are also going to discuss and introduce the historical aspects of various artificial refrigeration methods, its systems, and components, and its functions also. So we have the vapor compression refrigeration system, we have vapor absorption refrigeration system. So we have solar energy based refrigeration systems, air cycle refrigeration systems, we have steam and vapor jet refrigeration systems, and also we have thermoelectric refrigeration systems. So at the end of the lesson, you should be able to identify various natural and artificial methods of refrigeration, and also list salient points of various refrigeration techniques. And then you can also name important landmarks on the history of refrigeration. But in this lecture, I will not discuss yung history of each of the refrigeration systems. Ang discuss natin dito is history of refrigeration until magka-discover or maka-invent ng artificial refrigeration. So as part of our introduction, let us define what is refrigeration. So kasama naman to dun sa terminologies at dun sa PowerPoint presentation. But here are some of the definitions that we'll be using or can help you in order to be familiar on what this process means. So refrigeration is defined as the process of achieving and maintaining a temperature below that of surroundings. So the aim being to cool some products or space to the required temperature. So on our discussion of the syllabus, I iterated that refrigeration is a process of cooling. Ano, so naalala ba? Naalala ba yun?
Yes po, ma'am.
Yes po, ma.
We have distinction or we have the difference. Ano, we can differentiate it the refrigeration and cooling. Kasi although refrigeration is as
Okay, so again, anyone from this class who can differentiate refrigeration from cooling? Anyone? Okay, so for us to easily understand the difference between the two, ito na yung gagamitin natin na definition for refrigeration. So again, when we say refrigeration, it is a process of achieving and maintaining a temperature below that of the surroundings. For example, our surrounding temperature is an ambient temperature, and also meaning if we use refrigeration, then the temperature of the surroundings will be below that of the surroundings or below ambient temperature if we use refrigeration. Ano? But in terms of cooling, so cooling is a spontaneous process. So meaning if kahit wala kayong work input doon sa process, yes, bantayan.
Ma'am, excuse po. Ma'am, medyo hindi raw po maintindihan po yung iba po. Medyo mahina daw po sa kanila. Opo, thank you po.
Parang hindi ko speaker na sa akin. Pakinig na ba? Clear na or hindi pa? Hello? Clear na or hindi pa din?
Medyo malabo lang po, ma'am.
Hello? Clear na ba?
Okay, pa-confirm mo ulit kung clear. Hello? Malakas lang. Okay, so raise your hand lang kung kagaya nung kanina na hindi nahintindihan. Ano? Okay, pataas naman ako ng kamay pa clear na audio. Okay. So again, we can differentiate refrigeration from cooling. So yun yung huli natin, dinidiscuss kanina. So para mas maintindihan, gusto natin. Ano? Okay. So anyway, na kayang i-differentiate or have an idea on how to differentiate this refrigeration from cooling. Okay, so as I have mentioned, kanina we'll be using with this definition for refrigeration for better understanding. Ano? So, again, when we say refrigeration, maintaining a temperature below that of the surroundings. Mahina pa din ba? O okay na?
Medyo malabo lang po, ma'am, yung every word po. Pero hindi naman po siya choppy.
Okay. Sige. Hindi ko alam if may problema ba sa sounds ko. Sa mic. Okay, so again, yung refrigeration natin is maintaining a temperature below that of the surroundings. While cooling is a spontaneous process. So let us give an instance on how we're going to differentiate this. So in refrigeration, so let's start with spontaneous cooling. So yung difference ng cooling natin, again, it will leave a cup of coffee. For example, at 90 degrees Celsius, there will come a time that the temperature of the coffee will be the same and it's surrounding, pero hindi na siya mababa. So that is what we call as the spontaneous cooling. While yung sa refrigeration is if we put ice on that coffee. Ano? So, syempre, due to the transfer, bababa yung temperature ng coffee kasi nilagyan mo nga ng ice. Ano? So, there will be a temperature difference doon sa coffee natin dun sa surrounding. Ano? Pero, since the ice will continue to melt, so, dadating din yung time na the mixture of coffee with the ice will have the same temperature dun sa surrounding temperature. But in instance of refrigeration, when the temperature of the substance is below that of the surrounding, so again, that is what we call as the refrigeration. But yung process natin ng coffee until it reaches its surrounding temperature, is what we call as the spontaneous cooling. So wherein wala tayong work na ginawa. But in terms of putting ice, so that is one example of a simple refrigeration process. Wherein the temperature of that mixture, if you put ice, will be below that of the surrounding temperature. Okay? So, do you have the clear understanding between the difference of refrigeration and cooling? Pataas mo na kami today. Tayo. Okay. So, may lilipatan ba tayo? Ano na lang, lipat na lang or pa-encode dito sa encode messages yung meeting para if mag-end, before mag-end, ayun, lipat na tayo. Okay? Lipat na tayo ngayon para so let us continue. So other definition of refrigeration is it is a process of moving heat from one location to another by the use of refrigerant in a closed cycle. So again, one main example nito is yung mga ref ninyo sa bahay. So if you put, for example, meat and other goods doon, there will come a time that its temperature drops. So its main function is syempre to provide longevity dun sa food natin para hindi siya madaling masira. So that is one of the main application why we have these appliances at home. Para, and also, you can have cold drinking water in hot seasons. Okay, so again, when we say refrigeration, it is a process of removing heat. So again, if you put heat, then bababa yung temperature niya until sometimes kung siyempre sa freezer mo nilalagay, so mas bababa siya or magpa-froze siya. So in a way that, again, our main definition of refrigeration is maintaining a temperature below that of the surroundings. So refrigeration is simply cooling by removing heat but with the use of work input. again, yung cooling natin is continuous without word input. Ano, kung halimbawa, mag-lift tayo ng kape dyan, yung kamatan na lalamin yun, yung white chest, temperature, same with the surroundings. Ano, but in this one, it is a cooling by removing heat, and then again, yung temperature ng surroundings and also the substance is below that of the surroundings or the initial temperature. So we have here applications of refrigeration, which includes air conditioning, commercial refrigeration, and also industrial refrigeration. So one of the most important applications of refrigeration has been the preservation of perishable food products by storing them at low temperature. So same applications yung ginagamit nyo sa bahay. Ano? So again, there are lots of applications of refrigeration, which includes air conditioning, again, and industrial refrigeration. So refrigeration systems are also used extensively for providing also thermal comfort to human beings by means of air conditioning. So although this one is not part of our discussion because this is part of refrigeration, but we will also define what air conditioning means. So it refers to the treatment of air so as to simultaneously control its temperature, moisture content, cleanliness, odor, and circulation, which is required by occupants and process or products in the space. So let us now move on to this question. So which of the following can be called as refrigeration process? So since earlier we differentiated the refrigeration from cooling, and we also have defined what refrigeration means. Again, you are going to achieve and maintain a temperature below that of the surrounding. So we have here different instances. Hello. And can you provide your answer? Which of the following instances is a refrigeration process? So the main, again, para masagot ko, is that you have to understand that in refrigeration, a process of refrigeration is that you're going to maintain a temperature of a substance below its surrounding temperature. Okay? So, isa-isahin natin. And you can answer if it is a refrigeration process or not. So, let us start with Iranggoy.
Yes po, ma'am. Dilig po ba?
Yes, ma'am.
Yung one po ay hindi po siya refrigeration. Kasi room temperature po dapat ay below ng surrounding.
So that is correct. Hello. So next, letter B. Okay, so after reading, you're going to define your answer. Read the statement, then provide your answer, and then defend your answer. Okay, so next, great. Mendoza. Kurt Mendoza, you're next.
Pakinig ka po ako. Hello po.
Yes, okay.
Hello po.
Oo, tayo pakinig.
Refrigeration po, ma'am.
Okay, so again, our instruction is you're going to read, then you have to provide your answer.
Sige po. Cooling up a, letter B, cooling up a pot of water by mixing it with a large block of ice. Refrigeration process po siya. Dahil po gumamit po nung sa large block of ice, meaning po nag-cool po yung pot of water kaysa sa surroundings.
Okay, that is correct. So let us now move on to letter C, Aliam. Maxi.
Cooling of human beings using a ceiling fan. I think po refrigeration process din po siya. Since gumamit po ng ceiling fan para makul po yung human being.
Okay, meron ko dito may ibang sagot. Yes. Christian?
Yung sagot ko po ma'am ay hindi po siya refrigeration po. Gawa po ng yung temperature po niya ay hindi po bumaba sa surroundings po.
Okay, that is correct. Siguro, i-fill lang din natin. So, since example naman ay parang kaya naman natin siyang gawin. So, tumapat ka sa electric fan and then tingnan mo kung anong mangyayari sa body temperature or temperature of your surrounding. So, in a way, ang body temperature, same. Against ambient, para hindi tayo bababa below dun sa surrounding temperature. Okay? Kasi ang temperature natin ay parang mas mataas pa siya sa ambient temperature. Okay? Kasi body temperature natin, meron din tayong pinaprovide na body heat. So, ibig sabihin, this one is not an example of a refrigeration process. It's not an example. Okay? So, again, based on our main definition of refrigeration, so this is a process of maintaining a temperature below that of the surroundings. Yun lang lagi ang tatandaan. Okay, so next, letter D. Christine, Lucky.
Cooling off a hot cup of coffee by leaving it on a table. I think po it is not refrigeration po.
Okay. So that is correct. So since this is the same on our example, so this is a spontaneous cooling process. So next, Bridgel.
Brazil po, ma'am. Cooling of hot water by mixing it with tap water. Not refrigeration process po, ma'am.
Defend.
Gawa po ng ano po. Tape po, ma'am. Cooling of hot water by mixing it with water. Gawa po ng magiging room temperature lang po. Hindi po magiging ano po, surrounding temperature po.
Okay, so in this case, parang tama siya. Pero yun nga, yung kailangan natin malaman is the Curing, paano nangyayari yung sa heat transfer. Okay? So parang ma-identify natin that the temperature will be between or is equal to the temperature which is lesser kapag spontaneous. And in this case, yung tap water natin is somewhat similar to the ambient kasi nga siya ay tap water. So there will be no reason for it to drop the temperature below the ambient or the surrounding temperature, and that is correct. Okay, so next, last item is Alma
po, ma'am. Siguro po, cooling of water by creating vacuum over it. Ano po, siguro po siya ay not refrigeration.
Okay, so what is the idea of vacuum or creating a vacuum? Siyempre, vacuum is nagagawa siya kapag fully insulated.
Yes po, ma'am.
from outside its surroundings. So it insulated cooling of water by creating a vacuum over it. Ibig sabihin, we have a process cooling the water by creating a vacuum over it. Di ba nangyayari pag nagkaroon tayo ng vacuum? So yung, ano nangyayari?
So, bali
So,
po, refrigeration po siya po.
Depende.
Ayun nga po, nabanggit nyo rin po yung sa fully insulated po. Since yung basic knowledge naman po natin sa insulation po is na transferring ano po sa heat po or electricity. Meaning po yung hindi po na-adapt, mas bababa po siya sa surrounding natin since insulated po ang vacuum po.
Okay. So, we have to take note of each word, each item. And then, dapat alam din natin ano yung mga nangyayari. Ano din sa mga items natin. So, meron tayong word na vacuum. So, another example kung bakit nagagamit yung mga vacuum is that meron tayong mga tinatawag na vacuum pressure. So if the pressure inside an insulated is below the atmospheric, yung vacuum is below atmospheric pressure. So meaning, yung boiling and also freezing point of water decreases. Kaya kung sa steam table, so meron tayo doon saturation temperature, saturation pressure. So kung mapapansin nyo, kung titingnan ninyo yung saturation pressure below the atmospheric pressure, so mas mababa yung magiging boiling point ng water. So yung temperature para maging saturated vapor siya. Kasi kung, kung meron kayo yung steam table, you can browse it at 101.825 yung sa atmospheric. So ang boiling point natin, the boiling water is 100. So if we created a vacuum, ibig sabihin bababa yung boiling point. So bababa din yung sa freezing point. So it is the theory behind this item that I have. So now let us move on to our natural refrigeration. So in olden days, refrigeration was achieved by natural means. Since, syempre, in older days, wala pa naman artificial refrigeration ng mga panahon yun. So parang gumagamit tayo ng mga natural refrigeration to provide the main, or to get the main function of having refrigeration effect o yung sa pagpapalamig. So, again, in olden days, refrigeration was achieved by natural means such as the use of ice or evaporated air. So, in earlier times, ice ang ginagamit. So, ngayon, madali na siya makuha, so, using sa refrigerator. Pero that is an artificial refrigeration. Wherein yung ice natin is produced to refrigerator. So in earlier times, so ice was either transported from colder regions. It can also be harvested in winter and stored in ice houses for summer use. And this is made during night by cooling of water by radiation to the stratosphere. So we discussed the history of this natural refrigeration. Can you please read this slide?
Hello po. Natural refrigeration. In 1806, Frederick Tudor, who was later called as the King Ice, began to trade in ice by cutting it from the Hudson River and ponds of Massachusetts and exporting it to various countries, including India. In India, Tudor's ice was cheaper than the locally manufactured ice by nocturnal cooling. The ice trade in North America was flourishing business.
Ice was transported to the southern states of America in train compartments insulated by 0.3 of cork insulation. Trading in ice was also popular in several other countries such as Great Britain, Russia, Canada, Norway, and France. In this country, ice was either transported from colder regions or was harvested in winter and stored in ice houses for use in summer. The ice trade reached its peak in 1872 when America alone exported 225 tons of 1,000 tons of ice to various countries as far as China and Australia. However, with advent of artificial refrigeration, the ice trade gradually declined.
Okay. So what does nocturnal cooling? So nabanggit doon sa ating history of refrigeration, how it is being transported from one location to the location where it needed. So nabanggit doon what is nocturnal cooling. So we have here an art of ice making by nocturnal cooling. Kindly read this, Raniel. Mahina ba ang aking audio?
Ma'am, paulit nga po. Medyo malabo lang po kanina po.
Okay, kindly read the slide, Raniel.
Sorry po, nag-get po kasi. Art of ice making by cultural. In this method, ice was made by keeping a thin layer of water in a shallow earthen tray and then exposing the tray to the night sky. Compacted way of about 0.3 meter thickness was used as insulation. The water loses heat by radiation to the stratosphere, which is at around negative 55 degrees Celsius. And by early morning, the water in the trays freezes to ice. This method are popular in India.
Okay, so this nocturnal cooling uses about 20 meter thickness. So yung case, ito yung example for their compact. So not mediums and other mediums. So in old version, ginagamit for insulation or ito compacted green. So in this case, for nocturnal cooling, they make compacted of 20 meter thickness. Siguro depende pa din yung thickness ng extreme application. And then, gumagamit din tayo ng earthen tray. So, the concepts of projection during the previous in order to create ice and then through this nocturnal cooling. So, yung stratosphere is about negative 55 degrees Celsius, so the process of the transfer. So, yung water natin in a shallow earthen tray with proper insulation, ay pwede silang or nakapag-gawa sila ng ice through this process. Okay. And then, so ibig sabihin, kahit wala pang refrigerator, noong days, itong mga 1800s, halagay naman dito, year, 17, 16, or below that. So, at 1872, year ng mga malalapit no, so they can create ice, using nocturnal. Hindi pa na nag-develop yung refrigeration or artificial refrigeration that way, but they use, again, this type of system or cooling in order to provide ice. So in this case, we use the temperature of the stratosphere and use radiation in order to create ice. For the process of radiation. So next we have evaporative cooling. So kanina nabanggit na yung mga earthen trays. So these are the visual representation of the percentage. Siguro din sa mga K-drama na napapanood nila, di ba? May mga, ano po, depende, ewan ko kung nabanood nyo din. Ano, kasi dun sa, halimbawa, sa North Korea, ano yung mga store, yung ginagamit nila to store their meat and food. Parang nasa baba and using this earthen clay with insulation. Ano, so that is one of the example na talagang nagagamit siya. And then there are also a lot of history na kasama wherein ito, meron tayong mga natural refrigeration na ginagamit. So this process, parang ito yung naging start ano, to develop or produce yung mga artificial refrigeration nowadays. So again, we have here evaporative cooling. So this is a process of reducing the temperature of a system by evaporation of water. So evaporative cooling has been used for centuries to clean cold water in summer by storing water in earthen pots. So if this okay, so again, in this case, so this earthen pots is also yung mga haze, as part of insulation. So sometimes merong nakaalat siya sa lupa, So again, this part or natural refrigeration is evaporative cooling. So for example then, yung tayo, if we perspire and dissipate our heat or metabolic heat by evaporative cooling, if the ambient temperature or the ambient temperature is more than our skin temperature. So yung ating perspiration and dissipation of our heat, which is due to evaporative cooling, so yung ambient temperature natin will become or more than our skin temperature. So in this case, parang nagkakaroon siya ng cooling effect. Okay, so next we have yung cooling by salt solution. Meron ba kayong mabibigay na example in this case? Kasi parang ginagamit ko din naman siya nowadays.
Yung sa mga nagtitinda po ng ice cream.
Okay, that is correct. Tama yun. So, can you please read this slide, Maria Lourdes? So, yun yung isang example. Siguro ang ating is dati, parang mas matunaw yung yellow, pero iba yung science behind it. Kasi if we put salt solution or salt doon sa ice, so mas bumababa yung freezing temperature. So meaning, yung freezing temperature ng water or sa ice. So meaning, mas madami yung heat na kaya niyang ma-accommodate para mas mapalamig yung substance kung saan siya nagkakaroon ng contact. Okay? So, can you please read this again, Lourdes?
Cooling by salt solutions. Certain substances, such as common salt, when added to water, dissolves in water and absorb its heat of solution from water and the thermic process. This reduces the temperature of the solution, water plus salt. Sodium chloride salt can yield temperatures up to negative 20 degrees Celsius and calcium chloride up to negative 50 degrees Celsius in properly insulated containers. However, as it is the pr- as it is this process has limited application as the dissolved salt has to be recovered from its solutions by heating. A chemical reaction or physical change is endothermic if heat is absorbed by the system from the surroundings. In the course of an endothermic process, the system gains heat from the surroundings and so the temperature of the surroundings decreases.
Okay, so to have a better understanding of cooling by salt solution, I added a little, um, have a clear understanding in this. Okay, so wait lang. Kasi siya ay may ads. Okay. So, directly kasi ito sa ano. So, lipat natin.
Hey everyone, welcome back to my channel. Today's video is all about an interesting question. Does adding salt to ice lower its temperature? To find out, we're going to conduct a simple experiment and compare two glasses of ice, one with salt and one without salt. So, let's get started. We have two identical glasses with ice cubes in front of us. Make sure both glasses have the same amount of ice. And let's first measure the temperature of glass without adding salt. Initially, the temperature of both the glasses is 0.1 degrees Celsius. Now, we're going to add salt to one of the glasses and give it a good stir. Now, let's talk about the science behind this experiment. When salt is added to ice, it lowers the freezing point of water. The freezing point of pure water is 0 degrees Celsius, or 32 degrees Fahrenheit. But when salt is added to water, it interferes with the process of freezing, making it more difficult for water to freeze. This means that the ice will stay in a liquid state at a lower temperature than it would without salt. It is about more than 5 minutes since we added salt to ice. Okay, now let's check on our glasses of ice now. Let's first check the temperature of glass without ice. As you can see, the temperature of glass without salt is still 0.1 degree. Now let's check the temperature of ice with salt. As you can see, there is a drastic decrease in the temperature and it has decreased up to minus 12 degrees Celsius. Let's understand the reason behind it. When salt dissolves in water, it dissociates into its ionic form as Na plus and Cl ions. These ions get in between the water molecules, which makes it more difficult for the water molecules to organize themselves into a crystalline structure that is required for freezing. Since the salt ions interfere with the freezing process, the temperature required to freeze the water becomes lower, which means that it takes a colder temperature for the liquid to turn into ice. This is why adding salt to ice reduces the temperature at which it freezes. Table salt dissolves into 2 particles, but some other salts can dissolve into more particles and lower the freezing point even more. That's it for today. Thank you for watching this video. I hope you enjoyed our little
Okay. So what do you think are so kanina, dun sa experiment nila, yung nalagyan ng salt solution, yung temperature, ng mixture, which is yung salt, and then the ice, gives much lesser, compared dun sa walang salt solution. Lesser temperature, which becomes negative 12 degrees Celsius. So what do you think is the useful effect of providing or of having lesser temperature in terms of sa cooling? So, ibig sabihin, mas mapapatagal niya yung sa cooling effect. Kasi kung halimbawa, ice lang siya without salt solution, hindi niya, kumbaga mas mabilis. Kapag negative 12 degrees Celsius, ibig sabihin, mas matagal yung magiging cooling effect niya kasi mas mababa yung temperature niya. So, mas matagal siyang magpupunta sa zero. So, talaga, since din naman siya, wala tayong direct input, hindi naman lalagay tayo ng ice. So, talagang darating din naman yung matutulog yung sa salt solution. Pero, mapapatagal niya yung cooling effect. So, isa din yun dun sa idea na ginamit sa mga artificial refrigeration. Na, syempre, depende din sa function kung hanggang gaano kababa yung temperature na kailangan ng substance or sa application. So, ganun din dun sa mga design project, na gagawin. You also have to determine bakit ganun kababa yung temperature required dun sa iyong design, yung capsule design project. Kasi hindi din naman okay yung sobrang baba kung hindi din naman siya totally magagamit based on the application that you will give dun sa inyong design project. Okay? So, clear ba tayo dito?
Yes po, ma'am.
So now, let us move into our next slide. Okay. Kindly read and then provide also your answer just in Lilian on this slide.
Disadvantages of natural refrigeration methods are A. They are expensive. B. They are uncertain. C. They are not environment friendly. D. They are dependent on local conditions. I think po ay yung letter B and letter D. They are uncertain and they are dependent on local conditions.
Okay, defend your answer. Okay, pakinig ba ako?
Yes po, ma'am. Well, they are uncertain and dependent on local conditions since nakadepende po siya sa weather conditions. Kaya po uncertain. Nagbabago po kasi ang panahon.
Okay. So yung hindi nalagay siya dun sa that they are uncertain also. So that is correct. So the disadvantage is that it is uncertain and dependent on local conditions. Okay. So next, we have here another question. Okay. So pabasa muna and then all of you can provide your answer in our in-call messages. So can you read this, Aliyah? Aliyah Maxine, can you please read this slide?
Evaporative cooling systems are ideal for hot and dry condition, hot and humid condition, cold and humid condition, moderately hot but humid conditions.
Okay, so provide your answer here in our in-call messages. Okay. So let me call on Rain Castillo Bartolan More tunnel pala. Kindly defend your answer. So mostly, parang all pala. All of you answered letter A. So kindly defend it.
Bale,
Ang
ideal.
tinawag ko.
Good morning.
Yeah, day.
Bale, ideal po siya for hot and dry conditions, yung evaporative cooling system. Kasi, since nasabi po kanina na yung evaporative cooling po is for reducing temperature of a system and kailangan pong mag-obtain ng cold water sa summers to store water in earthen pots. So, that's why yung hot and dry conditions po yung ideal for this cooling system.
So, lahat naman kayo ay parang same answer. So, yeah. I hope clear naman dito. Okay, so let us now move on to the next. So here we are going to discuss the artificial refrigeration. So in our discussion of our syllabus, we also have discussed or identified the different components of refrigeration system. So again, those refrigeration systems have components for most commonly used. Or yung sa vapor compression systems, you have vapor absorption systems, gas cycle systems. But in here, depende doon sa system, syempre iba-iba din yung component. Yeah. So, ang mostly discuss lang natin sa the components, functions, and flow or process involved in this following systems. So, in terms of the computation, i-discuss din naman natin to mga cycles ito one by one. But for this introduction, we will only be discussing those components, functions, and process. Okay, so para pag nandito na tayo sa computation, parang alam nila yung process behind ng mga systems na yan, at least gagaili on how to solve the problems. Okay, so refrigeration, as it is known, this is produced by artificial means. So kanina na-discuss natin what are the natural refrigeration systems. So based on the theories or process or systems that involves natural cooling with natural refrigeration. So parang nagkaroon din ng development to provide this artificial refrigeration. So the history of artificial refrigeration began in the year 1755 when the Scottish professor William Cullen made the first refrigerating machine which could produce a small quantity of ice in the laboratory. So based on the working principle, refrigeration systems can be classified as vapor compression systems, we have vapor absorption systems, and we also have gas cycles. So before we start our discussion, we also have listed those refrigeration systems and those are the vapor compression refrigeration systems. We have the vapor absorption refrigeration systems. We also have the solar vapor absorption refrigeration systems. Next, we have the air cycle refrigeration systems. We have steam and vapor jet and thermoelectric refrigeration systems. So we will be continuing the discussion tomorrow on this artificial refrigeration systems. So since time na din naman tayo, so we'll continue our discussion tomorrow. Do you have any question before we end our meeting? Okay, so bukas ay discuss natin lahat ng artificial refrigeration na to. Para at least alam niyo yung components and also alam niyo yung function of each component and the flow of the system and also the main purpose of the system. So ano yung mga substances na ginamit, ano yung working flow rate na ginamit or possible na working flow na ginamit for this type of refrigeration systems. So, do you have any questions? How about you, Eva? Okay, so since we have 2 minutes, to anyone who can summarize our discussion today. Any volunteer who can summarize our discussion. So from time to time, every discussion I'll be calling names to summarize, to give what we learned on the meeting. Meron ba? Kasi nga kami kung meron, baka naman wala. Tatanong tayo, pero wala naman pala. Yes. Okay. Emmanuel. And then if meron kang gustong i-add, Alma, go next.
Hello po. Hello po, ma'am. Rinig po ba?
Oo.
So, yun po. To summarize the discussion, we first know what is the refrigeration and cooling. Ang difference po nila ay ang refrigeration ay yung pong temperature ay mas mababa sa surrounding temperature niya, and yung cooling naman po ay parang naging equilibrium lang. And then next naman po natin naaral ay yung about sa natural refrigeration system, na kung saan ay yun nga po sa early times po ay ice ang gamit ang natin, tsaka yung pong natural weather lang. Yun lang po.
Okay, do you have anything to add, Alma?
Mostly the same lang din po. Yun lang po. Yung sa base po is yung sa, kanina nga po, yung sa vacuum po yung nabanggit po. Another knowledge na rin po is fully insulated nga pong vacuum for refrigeration po. Yun lang po. Thank you po.
Okay, so again, tomorrow we will discuss the different artificial refrigeration systems. Anong oras tayo nga? Based on our schedule.